Hello students. So today I am doing class for class 10. The topic is the same topic that we were doing in the last online class, that is ratio and proportion. So this is the continuation class. Okay. So same page number is 98. The book used here is GANIT PRAKASH for class 10, and the question is 5 of number 6. Okay, so if x upon y is equal to a plus 2 divided by a minus 2, let us show that x square minus y square upon x square plus y square is equal to 4a, this whole divided by a square plus 4. Okay, now in this case, from given you have to prove that result. Okay, since there is x square minus y square upon x square plus y square is there, that is, you have to write down the given part and you have to square both the sides first. Okay, since we have got x square and y square on the left hand side. Okay, so here given is x upon y is equal to a plus 2 upon a minus 2. So first of all, you square both the sides. Okay, so you can square both the sides. So it is squaring both the sides. So squaring both the sides, what do we get? X upon y whole square is equal to a plus 2 upon a minus 2 whole square, right? So, or x square upon a square is equal to, now this square is for both numerator as well as denominator. So you can write a plus 2 whole square divided by a minus 2 whole square. Okay, now keep the left hand side as it is. So it is x square upon y square is equal to, now here you can use a plus b whole square. You know the formula, a square plus 2ab plus b whole square. So write down only the brackets, a square plus 2ab plus b whole square, right? So what is a here? It is a, this is the place for a, write a, and this is the place for b, that is 2. So this whole divided by, in the denominator also you have to use the formula a minus b whole square, that is a square minus 2ab plus b whole square. So it is a whole square minus 2 into a is a, what is b? It is 2 plus it is b whole square. Okay, is that clear now? Now let us simplify it. Or it is x square by y square is equal to, what is a whole square here? It is a square plus 4a, then plus 2 whole square is 4, whole divided by, in the denominator what do we write? It is a square minus 4a plus 4. So I think you have understood it. So now you have to prove x square minus y square upon x square plus y square. But we have only x square by y square here. So in this case, you have to use componendo and dividendo. So in the last online class, I told you about componendo and dividendo. So let us revise it now. What is componendo and dividendo? Okay. So now let us revise it. So this is the rough part. Okay. So I'm just telling you about componendo and dividendo. So what is componendo and dividendo? Let us revise it. So what is meant by componendo and dividendo? Okay. Suppose you have the relation a by b is equal to c by d. Suppose we have the relation a upon b is equal to c upon d. So by componendo and dividendo, what can you write? That is, on the left hand side, numerator is a, denominator is b. That is numerator plus denominator divided by numerator minus denominator is equal to. On the right hand side also you have to write numerator plus denominator divided by numerator minus denominator. Okay? Or you may write minus sign in the numerator on both the sides and write positive and you have to write positive in the denominator. Okay? Or you may write a minus b divided by a plus b is equal to C minus D divided by C plus D. It is just like your invertendo. Okay. So you can write either plus sign in the numerator on both the sides or minus sign in the denominator on both the sides. Okay. Or you may write minus sign in the numerator on both the sides and positive sign in the denominator on both the sides. So this is your componendo and dividendo, right? Now similarly here also you have to use componendo and dividendo. But since there is minus sign in the numerator, you have to prove that minus sign in the numerator. So while using componendo and dividendo, write minus sign in the numerator on both the sides and positive in the denominator, right? So or now it is, what is numerator here? X square minus what is the denominator? Y square divided by, in the denominator what do we write? Numerator plus denominator. Is that clear? Now what does right hand side become now? This is also the same case, numerator minus denominator divided by numerator plus denominator. So what is numerator here? A square plus 4a plus 4, right? Then comes minus sign in the numerator. And what is the denominator out here? It is a square minus 4a plus 4. This whole divided by. So in the denominator, what will you write? Numerator plus denominator. What is numerator here? A square plus 4a plus 4 plus. Then what is the denominator in this case? It is a square minus 4a plus 4. Is that clear to all of you? So I think you have understood it. This is just we're using componendo and dividendo. Here you can write by, here you can write in this case by componendo and what? Dividendo. By componendo and dividendo. So what do we get? X square minus y square upon x square plus y square, and the right hand side is there. Okay. So let us simplify it further. Or x square minus y square upon x square plus y square is equal to. So on the right hand side, it is a square plus 4a plus 4, then minus a square, minus to the minus plus 4a minus 4, this whole divided by, in the denominator, a square plus 4a plus 4 plus, next what is the second term here? It is a square minus 4a plus 4. So I think you have understood it. Okay. So now in this case you can cancel the similar terms but of opposite sign. That is a square minus a square gets cancels, plus 4a minus 4a gets cancels, and now in the denominator you can cancel this 4a minus 4a. Okay. So now, or x square minus y square divided by x square plus y square, which is equal to, now on the right hand side, what is 4a plus 4a? It is 8a, right? Same sign, you have to add them. Next, what is a square plus a square? Same, similar terms, same sign, you have to add them. 2a square, and then plus 4 is plus 8. Is it clear to all of you? Now you can simplify it further. What is common in the denominator? It is x square minus y square divided by x square plus y square is equal to 8a divided by, what is common here? 2 is common, so it is a square plus 4. Right? So this is 2 1s are 2, 2 4s are 8. Okay? So it is x square minus y square upon x square plus y square is equal to, so it is 4a divided by a square plus 4. Is it proved? So we have proved the required result. Okay, so it is proved. So in this case we have used componendo and dividendo to prove this number, that is 5 over number 6. Okay, so let's do the next question now. So now we will do question number 6 of number 6. So what is given here? If x is equal to 8ab upon a plus b, let us write by calculating the value of x plus 4a divided by x minus 4a plus x plus 4b divided by x plus 4b. Okay, so let us find out the value for x plus 4a upon x minus 4a from this given. Then again we have to find out the value for x plus 4b divided by I think it should be x minus 4b. Yes, x plus 4b divided by this is your x minus 4b. Okay, so here also let us use componendo and dividendo. So first of all, you have to simplify the given part. Okay, so here given is x is equal to 8ab divided by this is a plus b. Okay, now since we need x plus 4a, so let us simplify 8ab as 4a into what? Or x is equal to 4a into which number is 8ab? It is twice b divided by a plus b. Is it clear now? Now let us take this 4a to the left hand side. Since it is 4a into, so when this 4a goes to the left hand side, you should write it in the denominator on the left hand side. That is x upon 4a is equal to twice b divided by a plus b. So now in order to get the value for x plus 4a upon x minus 4a, let us use your componendo and dividendo. Since this is numerator upon denominator is equal to, this is also numerator upon denominator. So if you use componendo and dividendo in this case, you can easily get the value for x plus 4a upon x minus 4a. Okay, so let us write here by componendo and dividendo. By componendo and dividendo, what do we get? What do we get? Numerator upon denominator is there. You know componendo and dividendo now. So it is numerator plus denominator. That is x plus 4a divided by x minus 4a is equal to. On the right hand side also you have to write numerator. That is 2b plus, what is the denominator? A plus b, right? A plus b divided by, in the denominator you have to write numerator minus denominator. That is 2b minus a minus 2 plus minus b. Is that clear now? Or, so what is the value for x plus 4a upon x minus 4a? X plus 4a upon x minus 4a is equal to what? This is your 3b plus a. 3b plus a divided by what? B minus a. That is b minus a. Is that clear to all of you? So we have got the value for x plus 4a upon x minus 4a. Let us mark it number 1. Okay. Now similarly, you can get the value for x plus 4b divided by x minus 4b. Right. So again you have to write on given. So again from given part, we can get the value for x plus 4b upon x minus 4b similarly by using componendo and dividendo. Okay. So again x is equal to 8ab divided by a plus b. Now in this case you have to get the value for x plus 4b upon x minus 4b. So let us separate this 8ab in terms of 4b into what is 8ab? 4b into 2a. You know that, isn't it? So or x is equal to, let us write here 4b into what? 8ab, that is 2a. That is 2a whole divided by a plus b. Right? Now let us take that 4b to the left hand side. So actually it is 4b into 2a. So when this 4b goes to the left hand side, you should write it in the denominator. Okay? That is x upon 4b is equal to 2a upon a plus b. Okay? So now since you have to get the value for x plus 4b upon x minus 4b, let us use here componendo and dividendo again. Okay, so by componendo and dividendo, comma. So what do we have by componendo and dividendo? So in the numerator you have to write plus, and in the denominator you have to write minus. What is numerator plus denominator here? It is x plus 4b upon x minus 4b is equal to, so on the right hand side what do we get? 2a plus b, that is numerator plus denominator, divided by numerator minus denominator. So it is 2a minus denominator. So because of this minus sign, here the sign changes, minus a minus b. So is that clear now? So let us find out the value for x plus 4b upon x minus 4b. So therefore x plus 4b upon x minus 4b is equal to, what is this value now? 2a plus a is 3a plus b whole divided by 2a minus a is a minus b. So I think I've understood it. Okay, so we have got the value for x plus 4b upon x minus 4b is equal to 3a plus b upon a minus b. So now you have to get the value of this expression, isn't it? Let us write down the given expression now. So given expression is equal to x plus 4a upon x minus 4a plus x plus 4b upon x minus 4b, right? So now, so let us mark it as number 2. Since we have marked the value of x plus 4a upon x minus 4a as number 1, let us mark this x plus 4b upon x minus 4b as number 2. So which is equal to, so what is the value for x plus 4a upon x minus 4a? It is 3b plus a divided by b minus a. Okay, then plus, what is the value for x plus 4b upon x minus 4b? It is 3a plus b divided by a minus b. Is it clear now? So now in the next step you have to simplify it. So actually b minus a and a minus b are same expression. So in this case you have to make it b minus a by taking minus common here, so that you can easily get the LCM of b minus a and b minus a. So you should make it b minus a since it is b minus a here. Okay, so is equal to 3b plus a divided by b minus a plus 3a plus b divided by, in the denominator what is common? Minus is common, so it is b minus a, right? So now let us simplify it further now. Is equal to 3b plus a divided by b minus a. So again plus and minus is minus, right? So in the numerator 3a plus b, 3a plus b divided by, in the denominator what is there? It is b minus a. So let us take the LCM now. So what's the LCM here? It is b minus a. Okay, so b minus a and b minus a, what is their LCM? It is b minus a. Okay, now this LCM is divided by b minus a, that is 1 into 3b plus a, that is 3b plus a, right? Then comes minus sign here. Again this LCM is divided by b minus a, that is 1 time 1 into 3a plus b, 3a plus b, but because of this minus sign it becomes 3a minus into plus minus b. So is that clear? So let us simplify it. 3b minus b, 2b, and plus a minus 3a. Different sign you have to subtract, you will get 2a, but you have to write down the sign of the greater number, that is minus 2a. So whole divided by b minus a. Clear? So in the numerator what is common there? 2 is common, so it is b minus a divided by b minus a. So both of these will be cancelled. So which is equal to, what is the answer here? The answer is 2. So what is the simplified value of x plus 4a upon x minus 4a plus x plus 4b upon x minus 4b? It is 2 only. So this is the method for solving question number 6 of question number 6. Okay, so you can copy it. We'll do the next question now. So now, so we are doing question number 1 of question number 7. So it is if a upon 3 is equal to b upon 4 is equal to c upon 7, let us show that the value of a plus b plus c whole divided by c is equal to 2. So you can use K method here. So which is the given part here? Here given is a upon 3 is equal to b upon 4 is equal to c upon 7 is equal to k, suppose. Now this first is equal to second is equal to third is equal to k. So let us hide this second and third. Okay. So if you cross multiply it, what do we get? What is the value for a? A is equal to 3k, isn't it? So a is equal to 3k, right? Similarly, by hiding first and third, if you cross multiply it, what do we get? B is equal to 4k, isn't it? So it is b is equal to 4k. Similarly, by hiding first and second, what is the value for c? It is 7k, right? You can do cross multiplication out there. That is c is equal to 7k. So it is c is equal to 7k. Is that clear? Now let us prove that a plus b plus c whole divided by c is equal to 2. So let us write down left hand side here. So LHS is equal to a plus b plus c whole divided by c is equal to, what is the value for a in this case? It is 3k. What is b? 4k plus what is c? 7k divided by what is c again? You put 7k. Okay. Now let us simplify it further. So which is equal to 3k plus 4k, 7k plus 7k is 14k. So it is 14k divided by what is in the denominator, what is there? It is 7k. So you can cancel, k gets cancelled. So it is 7 1s are 7, 7 2s are 14. So which is equal to, what is the answer here? 2. Which is equal to your right hand side. Is that clear? So we'll do the next question now. So now we will do question number 3 of question number 7. So what is given here? If ax plus by whole divided by a is equal to bx minus ay whole divided by b, let us prove that each ratio is equal to x. So given here is ax plus by upon a is equal to bx minus ay divided by b. These ratios are given. You have to prove that this each ratio is equal to what? X. Okay. So now here given is, so here the given part is ax plus by upon a is equal to bx minus ay whole divided by b. Okay. So now what will you do here is, first of all, you multiply both the numerator and the denominator by a on the left hand side. And on the right hand side, you have to multiply both the numerator and the denominator by b here. Okay. So let us multiply it. So in both the numerator and the denominator on the left hand side, you multiply by a. Okay. A into ax plus by divided by a into a is a square. And in this case, on the right hand side, you multiply both numerator and the denominator by b. So b into bx minus ay whole divided by b into b is b square. Okay. So or now a into a square x plus this is aby whole divided by a square is equal to, this is your b square x minus aby whole divided by b square here. Now this is a square x, this is b square x. This is plus aby minus aby, this is a square, b square. So now what will you do? You have to prove that each ratio is equal to x. Now in this case, you can use addendo. So you know addendo. By addendo, we can write down that this each ratio is equal to. So now in this case, you have to use addendo, because you have to prove that each ratio is equal to x. Okay, so now in this case, by addendo we can add the numerator as well as denominator. That is, by addendo we can write down that each ratio is equal to add those numerators and add those denominators. Okay, so you will write by addendo, comma, we have, so we did it in the last online class. I told you about addendo. You have to add those numerators on the on both the sides, and those denominators on both the sides. You have to add them. Okay, so by addendo we have this each ratio. This each ratio means these two ratios is equal to. Each ratio is equal, you have to add those numerators now. What is numerator here? A square x plus aby plus what? Plus what do you write? B square x minus aby, this whole divided by. In the denominator, what do we write? It is a square plus b square. So I think you have understood it. This is by addendo. You can add those numerators and you can add those denominators. That is, each ratio will be equal to, that is, this each ratio will be equal to a square x plus aby plus b square x minus aby whole divided by, you have to add those denominators, that is a square plus b square. Is that clear? So now here you can cancel this aby minus aby will be cancelled. So is equal to, in the numerator, what is common out there? It is x. So within bracket, what do we have? A square plus b square whole divided by, in the denominator there is again a square plus b square. Okay, so you can cancel them. So which is equal to, what is the answer now? It is x. So we have proved that each ratio is equal to x. Okay, so this proved. So we can copy it. Now we'll do the next question now. So now we will do the next question, that is question number 1 of 8. So it is given that if a plus b upon b plus c is equal to c plus d upon d plus a, let us prove that c is equal to a, or a plus b plus c plus d is equal to 0. So this is the given part. You have to prove that either c is equal to a, or a plus b plus c plus d is equal to 0. Okay, so let us use the K method here. Okay, so here given is, so write down the given part, a plus b by b plus c is equal to c plus d divided by d plus a is equal to k, suppose. Okay, is equal to k, suppose, right? So hiding this second one, you can do cross multiplication here, isn't it? That is a plus b upon b plus c is equal to k is there. So you can do cross multiplication, right? That means what is the value for a plus b is equal to, this is k into b plus c. Let us mark it number 1, right? That's the next part. Again, hiding this first one, what do we get? C plus d upon d plus a is equal to k. So here also you can do the cross multiplication, right? That means we can write here c plus d is equal to k into, this is d plus a, right? Suppose this is equation number 2. Is that clear now? So we are getting the values of a plus b and c plus d from this relation, right? So now let us add them. Let us add 1 and 2 now. So let's see what happens. So you can add those left hand side, isn't it? A plus b plus c plus d. A plus b plus c plus d is equal to, so here k is taken common. So k is taken common here while adding these right hand sides. So k is taken common here, right? So k into within bracket b plus c plus d plus a. Is that clear to all of you? So b plus c plus d plus a means it is a plus b plus c plus d. So we are getting common term here, but in this case you cannot cancel them. Because why can't we cancel this a plus b plus c plus d? In the question it is given that a plus b plus c plus d must be equal to 0. That means you cannot cancel these two factors. You cannot cancel these two factors if you have to prove a plus b plus c plus d is equal to 0. So without cancelling, you have to take this right hand side to the left hand side. Okay? So or it is a plus b plus c plus d minus, let us take this right hand side term to the left hand side. So it becomes minus k into within bracket. Let us write it alphabetically. That is a plus b plus c plus d. I think you have understood it. Which is equal to what is there on the right hand side? It is 0. Is it clear now? So now what will you do? Let us take common out here. What is common now? Or it is a plus b plus c plus d is taken common from these two factors. A plus b plus c plus d is taken common. So within bracket, write down the remaining terms. It is 1 minus k is equal to 0. Okay? Since these two factors is equal to 0, you can write down that either first factor is equal to 0 or second factor is equal to 0. So you can write or a plus b plus c plus d is equal to 0, or you can write 1 minus k is equal to 0. 1 minus k is equal to 0. Is that clear? So we have proved that a plus b plus c plus d is equal to 0. So it is proved. Now we have to prove c is equal to a. Right? So, or since we have 1 minus k is equal to 0, or let's get the value for k here. Minus k is equal to minus 1. Minus minus gets cancels. So, or this is k is equal to 1. Now we have to prove c is equal to a. So let us put this value for k is equal to 1 either in equation 1 or in equation 2. You can put it either in 1 or in 2. Okay? So let us put this k is equal to 1 in equation 1. Putting k is equal to 1 in equation 1. Okay? So what is equation 1 here? It is a plus b is equal to k into b plus c. Is that clear? Next. Or a plus b is equal to, what is the value for k here? You can put k is equal to 1. So it is 1 into b plus c. Or a plus b is equal to b plus c. So you can cancel the common term b on both the sides here. It is plus b and they are on opposite sides. One is on the left hand side and one is on the right hand side. So you can cancel them. So what do we get? Or a is equal to c, or you may write c is equal to a. So we have proved both the parts there. That is c is equal to a, or a plus b plus c plus d is equal to 0. So write down hence c is equal to a, or a plus b plus c plus d is equal to 0. So it is proved. Is it understood now? So you can copy it. Now we'll do the next question now. So now we will do question number 2 of question number 8. Okay, so it is given that if x upon b plus c is equal to y upon c plus a is equal to z upon a plus b, let us prove that a upon y plus z minus x is equal to b upon z plus x minus y is equal to, you have to prove c upon x plus y minus z. You have to prove first is equal to second is equal to third out here from this given. So you can use your k method. Okay, so let us assume this given part is equal to k. Okay, So here given is, so what is given here? X upon b plus c is equal to y upon c plus a is equal to z upon a plus b is equal to k. Suppose, let us assume this given part, all these three is equal to k. So now this first is equal to second is equal to third is equal to k. Let us hide this second and third. What is the value for x? You can do cross multiplication there. So x is equal to k into b plus c, right? So therefore x is equal to k into b plus c. So let us mark it number 1. Similarly, hiding this first and third. What is the value for y? You can do cross multiplication here, isn't it? Y is equal to k into c plus a. You know cross multiplication, right? So therefore y is equal to k into c plus a. So this is your number 2. Again, hiding this first and second. What is the value for z? Z is equal to k into a plus b. Therefore z is equal to k into, this is your a plus b. Suppose this is number 3. So we have got the values of x, y and z by assuming the given part is equal to k, and we have marked it number 1, number 2 and number 3. So let us prove this. First ratio is equal to second ratio is equal to third ratio. Let us find out its value individually. Okay. So therefore first ratio. So what is the first ratio in this case? A upon y plus z minus x, right? So is equal to. Now let us keep this a as it is because we don't have the value for a out here, right? So write down a. What is y? Let us put the value for y. It is k into c plus a. K into c plus a. What is z? Plus k into a plus b minus, what is x here? It is k into b plus c. It is k into b plus c, right? So let us simplify it. So numerator remains same here, and you can take common k from the denominator, right? So is equal to a upon, so it is k is taken common. What do we get within bracket? It is c plus a plus a plus b plus a plus b, then minus b minus c, minus b minus c. Is it clear now? So you can cancel here. This plus c minus c plus b minus b gets cancels, is equal to a divided by k into 2a. Is it clear? So now here you can cancel this a gets cancels. So is equal to, this is 1 upon 2k. That is first ratio is equal to 1 upon 2k. So we got the value for first ratio is equal to 1 upon 2k. Okay. Now similarly you have to find out this value of the second ratio. So what is second ratio out there? It is b upon z plus x minus y. So let us write down the second ratio here. So what is the second ratio now? It is b upon z plus x minus y, which is equal to, now we don't have the value for b, so b remains same. So it is b upon, what is z? What is the value of z? The value for z is k into a plus b, right? So it is k into a plus b plus, what is the value for x? It is k into b plus c, right? It is k into b plus c minus, what is the value for y in this case? It is k into c plus a. It is k into c plus a. Again, similarly you can simplify this expression, right? So is equal to b upon, so what is common out here? It is k is taken common. So within bracket we have a plus b plus c, then minus c, minus 2 plus minus e. So I think you have understood it. So you can cancel here plus a plus c minus c. So it is b plus b is what? It is 2b. So is equal to b divided by k into 2b. So here bb gets cancels. So what do we get? it is also 1 upon 2k. That is, first ratio is equal to 1 upon 2k, second ratio is also 1 upon 2k. And now we have to prove that third ratio is also 1 upon 2k. Okay? So let us write down the third ratio now. Let us write down the, let us get the value of the third ratio here. So therefore, what is the third ratio now? So third ratio is equal to, what is it? Third ratio, C upon x plus y minus z. Okay? So here also the numerator, there is, in the numerator there is C. So C remains same. So which is equal to C upon, what is the value for x? What is the value for x? K into b plus c. It is k into b plus c plus, what is the value for y? K into c plus a. K into c plus a minus, what is z? It is k into, this is a plus b. Minus k within bracket a plus b. So I think you have understood it. Let us simplify this third ratio now. Let us simplify it. So is equal to C remains same divided by, similarly as before, you have to take k common from the denominator. So k is taken common. So within bracket what do we get? It is b plus c plus a, then minus a, minus into plus, minus b, right? So here you can cancel this, plus b minus a plus a gets cancels, is equal to c upon k into, what is c plus c? It is 2c. So here c1 is c, c1 is c, is equal to 1 upon, how much is it? It is 1 upon 2k. Is that clear now? So we have proved that first ratio is equal to second ratio is equal to third ratio is equal to 1 upon 2k. Hence, that question is proved. So you have to write. So what will you write here? Hence a upon y plus z minus x is equal to b upon z plus x minus y is equal to, since there is no space there, so we will write it in the next step. C upon x plus y minus z. So we have proved it. Okay? So it is done, proved. So I think I have understood it. So we'll do the next question now. So now we will do the next question, that is question number 3 of question number 8. So what is given here? If this is the given part, x plus y upon 3a minus b is equal to y plus z upon 3b minus c is equal to z plus x upon 3c minus a. Let us prove that x plus y plus z upon a plus b plus c is equal to ax plus by plus cz divided by a square plus b square plus c square. So this relation is to be proved, that is LHS is equal to RHS. So here also let us use the k method. Let the given part is equal to k. Okay, so here the given is x plus y upon 3a minus b is equal to y plus z divided by 3b minus c is equal to z plus x upon 3c minus a is equal to k suppose. Is equal to k suppose, right? So in this case we can equate first and last. We can equate first and last to get the value for x plus y, isn't it? So hiding this, you can get the value for x plus y in terms of k by cross multiplication, isn't it? So, or hiding this, what do we get? Hiding this, x plus y is equal to k into 3a minus b. X plus y is equal to k into 3a minus b. So let us mark it number 1, right? Similarly, you can equate second and last. That is y plus z upon 3b minus c is equal to k. So if you do cross multiplication in this case, that is second is equal to last, we can have y plus z is equal to k into 3b minus c. Suppose this is equation number 2, right? So again you can equate this third is equal to k. So this third is equal to k. Again you can do cross multiplication out here. So what do we get? That is we get z plus x is equal to k into 3c minus a. So you can mark it as number 3. Is that clear now? So now what will you do in the next system now? What will you do with this 1, 2 and 3? Let us add them. Okay? Because we are simplifying it. Because you have to get both the values of this left hand side as well as right hand side. And they should be equal. Okay? So adding 1, 2 and 3. Adding 1, 2 and 3. So what do we get? Adding 1, 2 and 3. Let us add them. Let us add 1 plus 2 plus 3. So x plus x, it is 2x plus y plus y, 2y plus this z plus z, that is 2z, which is equal to. Now on the right hand side. On the right hand side you have to add all these right hand sides. K common. So within bracket what do we get? 3a minus a, 2a plus 3b minus b, 2b plus next 3c minus c plus 2c. So I think you have understood it. Okay. So or what is common on the left hand side? 2 is common. 2 into x plus y plus z is equal to. So on the right hand side again what is common here? 2. 2 is taken outside the bracket. Okay. 2k. So 2k within bracket we have a plus b plus c. Is that clear to all of you? So here you can cancel this 2 gets cancels. So what do we get? It is x plus y plus z is equal to k into a plus b plus c. So let us mark it number 4. Let us mark it number 4. Is that clear to all of you? So now what will you do in the next step? Since the left hand side here is the expression x plus y plus z upon a plus b plus c. Okay. So from this 4 you can get the value for x plus y plus z upon a plus b plus c. That means in equation number 4 this a plus b plus c should be taken to the left hand side. Since it is k into is there. So when you take this a plus b plus c to the left hand side you should write it in the denominator. So what do we get here? X plus y plus z divided by a plus b plus c is equal to k. Let us mark it number 5. That means we are getting the value for left hand side, isn't it? So what is left hand side here? X plus y plus z upon a plus b plus c. What is this value? It is k. Again, in order to prove these two relations, LHS is equal to RHS, you should prove that ax plus by plus cz upon a square plus b square plus c square is equal to k also. You have to prove that this right hand side is also k. Is that clear? So what is the method for proving this right hand side also is equal to k? So what we will do here is from 4 let us subtract 1. From 4 let us subtract 1. What do we get? X plus y will be cancelled, we will get the value of z. Let us subtract 4, let us subtract 2 from 4. What do we get? Y plus z will be cancelled, we get the value of x. Let us subtract this 3 from 4. What do we get? This z plus x will be cancelled, we will get the value of y. Okay? So let us get those individual values of x, y as well as z. Let us find it. Okay? So now, therefore, let us write number 4 now. X plus y plus z is equal to k into a plus b plus c. Right? This is from number 4. Let us subtract number 1 here. Now x plus y. X plus y is equal, what is x plus y? K into 3a minus b. Let us subtract it. Okay? That means we are subtracting this 1 from 4. Right? So this is minus minus, this is minus. So here you can cancel this xx and yy gets cancels. So what do we get? Now in this case we get the value for z, isn't it? So is equal to, that means z is equal to, what is common here? K within bracket a plus b plus c, right? That is the numerator part. K is taken common out here. Then you have to write down not the numerator part, that is the first term of this right hand side. Now what will be the second term of this right hand side? Minus 3a and minus minus plus b, right? So let's simplify it. Therefore z is equal to k within bracket b plus b is 2b, that is b plus b is 2b, then a minus 3a minus 2a, then it is plus c. So that is the value for z. Let us mark it number 6. Let us mark it number 6. So now what will you do in the next step now? So in the next step, let us subtract these 2 from 4. Let us subtract these 2 from 4, right? So let us write down 4. Again, what is number 4 there? From 4 we have x plus y plus z is equal to what? K into a plus b plus c. K into a plus b plus c, right? From here, let us subtract this number 2. That is y plus z is equal to what? This y plus z is equal to k into 3b minus c. K into 3b minus c. Okay? So what do we get now? Let us subtract it. This is minus minus, this is also minus. So here y cancels, z cancels. So we will get the value for x here. X is equal to, again what is common here? K is taken common within bracket. What do we get? A plus b plus c, right? Then minus 3b. K is taken common here. But since this is minus into plus, minus 3b, minus into minus plus, this is c. Or x is equal to k into, let us simplify it. C plus c, let us write 2c. Then minus 3b plus b minus 2b, then you have to write plus a. So let us mark it number 7. That means we are getting the value for x. Is it clear? Now let us subtract these 3 from 4 to get the value for y. Okay? So now let us write this number 4. Again, what is number 4? X plus y plus z is equal to k into a plus b plus c. And you have to subtract 3 from 4. What is number 3? Number 3 will be z plus x is equal to k into 3c minus e. Let us subtract it. Okay? So you have to change the sign here because we are subtracting, right? So z gets cancels, x gets cancels. So what do we get? It is y is equal to. So what is common in this case? So k is common here, isn't it? So k is taken common within bracket a plus b plus c, then minus 3c. Minus 3c, minus to minus, plus a. Is that clear now? So now, or y is equal to, now this is k into, let us write a plus a, 2a. Is that clear? Minus 3c plus c, minus 2c, and this is plus b. So we get the value for y. So let us mark it number 8. So in number 6, we get the value for z. In number 7, we get the value for x. And in number 8, we get the value for y. Let us put this value on the right hand side to be proved. So what is to be proved here? X plus y plus z upon a plus b plus c. We have already got the value for x plus y plus z upon a plus b plus c. That is from number 5. It is k. Again, you can prove this right hand side is equal to k. So let us put these values of x, y and z on this right hand side to prove this right hand side is equal to k. Okay? So now let us write down the right hand side now. So what is RHS here? Ax plus by plus cz whole divided by a square plus b square plus c square. Now you should prove here that this ratio is equal to k. Then only we can write this LHS is equal to RHS, because the value for LHS is already determined, which is equal to k. Okay, so is equal to, now a into what is x, put the value of x, that is k, 2c minus 2b plus a, right? Similarly, plus b into what is y, what is the value for y? It is k into what? K into 2a minus 2c plus b. Okay, since there is no space out there for the third one, let us write it in the next step, plus c into k into what will be there? What was the value for z? Can you tell me what was the value for z? It should be 2b. It should be 2b minus 2a plus c. That is your value for what? Z. That is value for z is k into 2b minus 2a then plus c. Okay, so whole divided by what is there in the denominator? You should write a square plus b square plus c square. That is, denominator remains same. So I think you have understood it. So let us simplify it further. So which is equal to, what is common here? K is common within bracket. Now let us multiply it. Now we have to multiply 2c minus 2b plus a by a. That is 2ca minus 2ab plus a square, right? Next, plus k is taken common out here, plus 2ab minus 2bc plus b square. Is that clear? Next, since again there is no space there, let us write it in the next step. Plus k is taken common out here. Now multiply by c there. C into 2b, 2bc minus 2ca plus c square. Okay, whole divided by, here bracket is closed. Whole divided by, what do we write here? It is a square plus b square plus c square. So I think you have understood it. Okay. So now let us simplify it further. Now here you can cancel here, plus 2ca minus 2ca, right? Minus 2ab plus 2ab minus 2bc plus 2bc will be cancelled. So which is equal to k, what are the remaining terms here? It is a square plus b square plus c square whole divided by, in the denominator you write a square plus b square plus c square. Both of these will be cancelled, which is equal to k. That means already we have got the value for left hand side, that is x plus y plus z divided by a plus b plus c was k. Also we got the value of this right hand side, that is this right hand side is also k. That means both of these left hand side and right hand side are equal, right? So hence you can write, so we have already got the value for x plus y plus z divided by a plus b plus c as k. Also we got the value for x plus by plus cz divided by a square plus b square plus c square is equal to k. That means you can write x plus y plus z by a plus b plus c is equal to what? ax plus by plus cz divided by a square plus b square plus c square. So it is proved. Is that understood now? So this is quite a complicated problem, but if you practice it, you can easily do it. Okay, so you can copy it. We'll do the next question now. So now we'll do the next question, that is question number 1 of 9. So what is given here? If 3x plus 4y upon 3u plus 4v is equal to 3x minus 4y upon 3u minus 4v. So it is the given part. You have to prove that x upon y is equal to u upon v only. You have to prove it. Okay. So let us write down the given part again. So here given is 3x plus 4y divided by 3u plus 4v is equal to 3x minus 4y divided by 3u minus 4v. Right? So now in this case you have to use componendo and dividendo to prove that required result. Okay? So in order to prove it, let us keep the terms containing x and y on the left hand side and u and v on the right hand side. That means you have to exchange this 3x minus 4y and 3u plus 4v. You have to exchange their sides. That means 3x minus 4y take it to the left hand side and 3u plus 4v take it to the right hand side. That means you can cross multiply here also. 3x minus 4y comes out here and 3u plus 4v goes to the numerator on the right hand side. Okay. So what do we get? It is 3x plus 4y divided by, let us take this to the left hand side. That is 3x minus 4y, which is equal to, on the right hand side, what do we get? So it goes to the numerator on the right hand side. That is 3u plus 4v divided by 3u minus 4v. Is that clear? So now you can use componendo and dividendo. You know componendo dividendo, isn't it? So by componendo and dividendo, comma, we have, so let us write positive sign in the numerator. That is numerator plus denominator in the numerator divided by numerator minus denominator in the denominator. Okay. So what is the numerator here? 3x plus 4y plus. What is the denominator in this case? 3x minus 4y. This whole divided by, in the denominator, what do we write? Numerator minus denominator. That is 3x plus 4y minus 3x minus to minus plus 4y, which is equal to. Now on the right hand side also you have to use the same method. That is numerator. What is numerator? 3u plus 4v plus, what is the denominator? 3u minus 4v whole divided by, in the denominator, what do you write? In the denominator, what do we write? Numerator, that is 3u plus 4v minus 3u minus 3u minus and minus plus 4v. So we are using here componendo and dividendo to prove the required result. Okay. So here you can cancel here. This 4y gets cancels. 3x also gets cancels. So here also 4v gets cancels. Here 3u gets cancels. So what do we get? Or now it is 3x plus 3x, same sign, add them, 6x. So it is 6x divided by 4y plus 4y. This is 8y is equal to, next on the right hand side, 3u plus 3u, 6u. 6u divided by, what is 4v plus 4v? That is 8v. From both the sides in the numerator there is 6. So we can cancel this common term from both the sides in the numerator, and you can cancel this common term which are in the denominator. That is 8 ones are 8, 8 ones are 8. So that is what do we get? X upon y is equal to u upon v. So we have proved the required result. That is x upon y is equal to u upon v. That is proved. Is it clear now? So now next we'll do the next part. So now we will do the next question, that is 2 of question number 9. So if a plus b plus c plus d is 2, A plus B minus C minus D is equal to A minus B plus C minus D is to A minus B minus C plus D. Let us prove that A is to B is equal to C is to D. So you have to prove this relation, that is A is to B is equal to C is to D from given. Okay. So let us write down the given part here. That is A plus B plus C plus D is to A plus B minus C minus D is equal to, it is right on the right hand side. So this is the given part. Is to A minus B minus C plus D. Okay. So you can write down this ratio in terms of fraction. Okay. So or A plus B plus C plus D divided by A plus B minus C minus D, which is equal to, on the right hand side also you can write it in terms of fraction. Ratio means fraction, isn't it? So A minus B plus C minus D divided by A minus B minus C plus D. Is that clear? So now use componendo and dividendo here also. So by componendo and dividendo. So what do we get? By componendo and dividendo, okay? Let us write plus sign in the numerator and negative sign in the denominator. That is numerator plus denominator. That is, what is numerator here? A plus B plus C plus D plus. But because of this plus sign, the sign will not be changed. That is plus, what is denominator? A plus B minus C minus D. Whole divided by, in the denominator also, numerator minus denominator. What is numerator? A plus B plus C plus D. But because of this minus sign, because of the minus sign, the sign of the denominator will be changed. So because of minus sign, the sign of these terms will be changed. That is minus A minus B plus C plus D, which is equal to, that is minus A minus B minus U minus plus C minus U minus plus D is equal to, on the right hand side also, numerator plus denominator. What is numerator? A minus B plus C minus D plus. What is the denominator here? A minus B minus C plus D. This whole divided by numerator minus denominator. So what is numerator here? A minus B plus C minus D minus denominator. What is minus denominator? Minus A minus U minus plus B minus U minus plus C. Because of the minus sign, the sign will be changed for the denominator. Minus A plus B plus C, then minus D. Is that clear now? So let's simplify it. So here you can cancel. Plus C minus C will be cancelled. Next, plus D minus D will be cancelled. So here AA and BB will be cancelled. And here plus C minus D plus D. And here plus A minus A, then minus B plus B will be cancelled. Okay. So what are the remaining terms now? Or A plus A, 2A plus B 2B divided by, in the denominator, 2C plus 2D is equal to A plus A, 2A minus 2B divided by C plus C, 2C minus D minus 2D. Okay. So we got this simplified relation. So again 2 is taken common out there. Again you can take 2 common there. Okay. So or 2 is taken common here within bracket. A plus B divided by, here 2 is common. It is C plus D is equal to, here is also 2 is common. It is A minus B divided by, 2 is common here. It is C minus D. Is that clear? So here 2 gets cancels, you can cancel them. So what do we get? A plus B divided by C plus D is equal to A minus B divided by C minus D. Okay? But the answer is not proved here. But you have to prove that A is to B is equal to C is to D. But here we have A plus B upon C plus D is equal to A minus B divided by C minus D is there. Okay? But you have to prove A is to B is equal to C is to D. Similarly, as in the previous problem, let us keep the terms containing A and B on the left hand side and C and D on the right hand side. Then again you can use componendo and dividendo. So what will you do here is A minus B, take it to the left hand side. A minus B comes in the denominator here. And when the C plus D goes to the right hand side, it goes to the numerator side. Okay? So what do we get? A plus B divided by, exchange their sides. A minus B comes out here in the denominator is equal to C plus D goes to the numerator on the right hand side. Okay? Divided by C minus D. So now in order to prove A is to B is equal to C is to D, again you have to use componendo and dividendo. Okay? So again by componendo and dividendo comma we get. So what do we get? So again you can use componendo and dividendo again, that is numerator plus denominator in the numerator, that is A plus B plus A plus and minus B divided by denominator. What is denominator here? A plus B, then minus A plus B. Minus A minus to minus plus B. Because of this minus sign will be changed. Is equal to, similarly on the right hand side, that is numerator plus denominator. So here it is C plus D plus C minus D whole divided by, that is numerator plus denominator, that is C plus D plus C minus D whole divided by, in the denominator what do we write? Numerator minus denominator, that is C plus D, then minus C minus to minus plus D. Is that clear now? So now let's simplify it. Here BB gets cancels, here A gets cancels, and on the right hand side you can cancel this D, and here you can cancel this C. So what do we get? What is A plus A? Same sign, add them to A. What is B plus B? 2B is equal to, what is C plus C? 2C divided by what is D plus D? It is 2D. So here 2 gets cancelled, here 2 gets cancels. So again what do we get? That is A upon B is equal to C upon D, right? Or you can write in the ratio, in terms of ratio, what can you write? A is to B is equal to, this is your C is to D. So A is to B is equal to C is to D. We have proved it. Okay? So it is proved. So I think you have understood it. So you can revise it. You can copy it. Now I'll give you the homework. Right? And so now I am giving you the homework. The homework are this one, that is homework 7 number 2. 2 of question number 7. That is, if A upon Q minus R is equal to B upon R minus B is equal to C upon P minus Q, let us show that A plus B plus C is equal to 0, again is equal to PA plus QB plus RC is also 0. So you have to prove the two parts out here, A plus B plus C is equal to 0, and also you have to prove that right hand side, PA plus QB plus RC also equal to 0. Okay? So in this case you can use the K method, right? A upon Q minus R is equal to B upon R minus B is equal to C upon P minus Q is equal to K. And from there, after cross multiplication, that is equating first and last, second and last, and third and last, you can get the values of A, B and C. You will get the individual values of A, B and C, and prove that A plus B plus C is equal to 0, and also prove that PA plus QB plus RC is equal to 0 by putting those values of A, B and C in terms of K. So you can do it. Okay. So 8 number 4 is also if x upon a is equal to y upon b is equal to z upon c. Let us show that this x square minus yz upon a square minus bc is equal to y square minus zx upon b square minus ca is equal to z square minus xy whole divided by c square minus ab. So here given part is x upon a is equal to y upon b is equal to z upon c. You can use the k method here also. So x upon a is equal to y upon b is equal to z upon c is equal to k, suppose. Okay. So I am giving you the hints also. So if you write x upon a is equal to y upon b is equal to z upon c is equal to k, suppose. So equating first and last, that is x upon a is equal to k. So after cross multiplication we get the value for x is equal to ak. Similarly equating second and last, y is equal to bk. Again equating third and last, and by cross multiplication you will get z is equal to ck. Okay. Then you have to prove this first ratio is equal to second ratio is equal to third ratio. So let us write down first ratio is equal to x square minus yz upon a square minus bc. Then here you can put the values of x, y and z in the numerator in terms of k, get its value. And second ratio, write down second ratio, put the value for y, z and x here also, simplify it and get the value of the second ratio. And also you write down the third ratio, put the value for z, x and y here, and also simplify that third ratio. All these first ratio, all the values of first ratio, second ratio and the third ratio must be equal. So in this case you can use that K method. Is that clear to all of you? So revise all the problems that we did today, and also you can do these two problems as homework and you practice all those we have finished till now. Okay, so this much is for today. So we'll do more problems in the next class from the same chapter, that is ratio and proportion. Okay.